Right, so today we're going to extend on our understanding of when we talked about proportional relationships and non-proportional relationships. When we looked at those, we came up with an equation that would represent essentially how we graphed these linear equations that we came up with. So I want you guys to remember we came up with the equation that y is equal to mx, and then if it didn't have a plus or a minus, we knew that that was proportional and that it would start at 0, 0 on the or the origin of the coordinate plane. But then we had some that were non-proportional where we added or subtracted a b. So we're going to do a quick review of what each of these things here is representing. So the what is represented by m is the slope, and the B represents where our line is going to intercept the y-axis. So this right here, it represents our y-intercept, or where it crosses on that y-axis. So if the graph is proportional, we know that the equation will be written in the form of y is equal to mx, because we know it's going to cross at 0, so we don't have to add a 0. However, if the graph is non-proportional, we know that the equation is going to be written in the form of y is equal to mx plus b. Right, so that's just our quick review and takeaway from what we learned in regards to the proportional and non-proportional relationships. So if we continue through this, we're going to talk about equations of horizontal lines, and you can remember horizontal lines going from right to left. Think of the horizon as the sun. Okay, so right to left, and then we're going to look at equations of vertical lines. So if a graph of a horizontal line, so if that's what it's going to be, then the y value is constant. Therefore, equations of horizontal lines will always begin with y, okay, or y equals, right? So these we can see when we have horizontal lines, it'll say y equals 5, right? If our graph is of a vertical line going up and down, and we can think of that v as an arrow that we can add that point up and down to. If it is that vertical line, then our x value is going to be our constant, and we can represent our equation by starting it with x is equal to. So we're going to explore that a little bit more as we go throughout this situation. So if I find the slope, the y-intercept in the equation for the graph below. So this is going through and doing a lot of review. We kind of looked at these, and we can go through and answer some questions. So we can figure out some basic information. So I know that my slope is going to end up being, if you remember, rise over run. So I can figure that out super easily. I'm going to go here and put a dot, and then I can go, and so this one goes here, and then I can put a dot right here. Okay, however we so choose to do that. Now, what I do notice that this is counting by ones and this is counting by twos. So it's helpful for me to say that this is, I go 0 on my x-axis and then I go 4. And then here I went 2 on my y-axis and I went to 6. So you have to pay attention to the scale. If I just did my run of my rise of 1 and over 2, that would give me the wrong answer. So what I really have here is 6 minus 4 over 2 minus 0, which is going to end up equaling, I think I have a mistake, guys. Do I have a mistake? I don't have a mistake. I was thinking I wrote 8 here. So 6 minus 4 is going to be 2, and then 2 minus 0 is going to be 2, and then that's going to give me a 1, so my slope is 1. Okay, so when we're looking at my slope is going to be 1. All right, so now my y-intercept is where it intersects that y-axis at. So if I'm looking at my graph, I can clearly see that this right here is my y-axis, and it intercepts it at that positive 4. Okay, so we intersect at that positive 4. So now I can write an equation where y is equal to my m, or my slope. If we remember, this is my m, okay, and this is my b. Okay, y is equal to 1x, or I can just put x because that's 1x right there, plus 4. And my question is this graph proportional? And my answer is no. Yes, it is a line, but it does not go through the origin, which is right here, so it is not proportional. Okay, so let's look at our second one. All right, so When I look at this line is pointing in a downward direction. So I know first before I even do anything that my slope is gonna be negative. All right, both of these, I'm gonna pay attention to my axis right here. Both of these are counting by 2. So I'm gonna give myself a point here and I'm gonna give myself a point here. So this one is at -6, 0. And this one is at 0, -4. Okay, so we're going to just take a brief moment, look at what we have here. So I have a -4 minus 0 over 0 minus a -6. Okay, so this is going to end up equaling a -4. And then 0 minus a -6, or I'm going to add the opposite, is just going to be 6, which I can simplify that to a -2/3. So my slope is a -2/3. All right, so now my y-intercept, again, remembering that this right here is my y-axis. Where does it cross the y-axis? And the answer there is that it crosses is at a -4. So my equation that I'm going to have here is y is going to equal a -2/3 x minus 4, because I have a negative y-intercept. Okay, so is this proportional? My answer here again is no, it is not proportional because it does not cross through the origin. Yes, it's linear, but it does not cross through the origin. All right, so let's look at number 3, and this is on our second page. So right now I have a graph, and this line on this graph is horizontal. So if we remember and we go back to our notes, we know that the minute that we have a horizontal line that our slope is 0. Like, I don't necessarily have to, if you can remember that, that's fine. If you can't remember that, it's pretty easy to remember that, if I did 2 points on my line, I did there and I did there. So I have 0, 4, and then I have 2, 4. So 4 minus 4 over 2 minus 0 is going to end up giving me 0 over 2. So if I have 0 pieces out of 2 pieces, I have 0. Okay, so that's one way that I could prove that my slope is 0. Okay, there's no rise or run involved in any of this. Like, if you're riding your bicycle, you're just going to keep going straight all the way through, no incline or decline. All right, so my y-intercept here, again, looking at my y-axis, is where it crosses my y-axis at, and it crosses it right here at the +4. So my equation for this is y is equal to 4. Okay, so that's the concept of what we were talking about when we were reviewing what a equation looks like for a horizontal line. Okay, so I don't have a slope, so I don't have to put mx. All right, now is this graph proportional? My answer here is no, because again, it doesn't go through the origin. All right, so now we're going to look at this slope right here. And this one right here is showing a vertical slope. And if you remember, if we have a vertical slope, we said the slope was undefined. And we can reason through that by putting 2 points on the line if we so choose to do so. So if I put this point on the line, it's a -6, 2, and then I have a -6, 0. So I could have a 0 minus 2 over -6 minus a -6. I would end up with a -2 over 0. You can't have -2 out of 0 pieces. So if you started off with 0 pieces, you can't have a -2 or even a +2 for that matter. So that is why it's considered undefined. If you had 0 pieces, you couldn't cut it up or share it among people. All right, so right here, do I have a y-intercept? Is it crossing this y-axis anywhere? And my answer here is that there is none. Okay, there's no y-intercept, none. All right, and then the equation that would go with this is the fact that x is equal to a -6. So if it's vertical, it's crossing our x-axis, it's crossing our x-axis right here, not our y-axis. And so we have x is equal to -6. Again, if this graph is proportional, it would have gone through the origin, which it did not. So this is not a proportional graph. Okay, so as we work down to our last 2 problems, we're going to explore these in a real-world situation. So we're going to look at the following situations that could be modeled by the graph below. All right, so we know, first off, I'm just going to analyze the graph. First off, what I notice about this graph is that it is a negative slope. The second thing I notice about this graph is that it's non-proportional. Okay, so if I had to notice two things about this graph, it's non-proportional. The other thing that I can notice about this graph just by looking at it real easily is that my y-intercept is equal to 100. All right, so let's see if I can figure out any of these that would match it. All right, so Elena has $100 in her bank account. Ooh, that's good. Every 3 days, she saves another $10 and adds it to her bank. Now, she's adding money to her bank. Yes, we have $100 here, which would match that. That would match. But the fact that she's adding money to her bank would not suggest that the line would be going down. It would show that her money in her bank account would be growing. So this one cannot be the answer because she's adding money. That would be a positive slope. Right. B, Hunter weighs 100 pounds. Yep, we got that 100, which is good. And his goal is to gain weight for football. He gains about 10 pounds every week. All right. Again, if he's gaining weight, would we have a positive or a negative slope? If he's gaining weight, his weight would be going in that direction. So our slope here would be positive. So that is not the correct answer. Let's just verify that C works. All right. Dawn's pond is 100 meters deep, but her city hasn't received much rain. As a result, the pond level decreases by 10 meters every 3 days. That makes sense. So we have our 100 meters, which is where we start. That's our starting point, the 100 meters. And then because there hasn't been much rain, we have a decrease in the amount of water in her pond. So C is the correct answer right here. So on this one right here, when you go to Edge Elastic, there's not much that you can create, but we can certainly look through here and figure out a real world situation that could be modeled with this one. And I took this off your idea, but we could certainly figure something out. So if we look at our first graph, we're at 0. We're at 0, 2, so that's our point. So if I were to start writing an equation, I would say y is equal to, and I know it's going to be a positive slope, so something x plus 2, because that's where it's crossing, okay? And then I can figure out what my slope is. So my first point here is 0, 2. My second point is 6, 4. All right, so if I want to figure out my slope, I'm going to go down here really quickly and do that. 4 minus 2 over 6 minus 0 is going to equal 2 over 6, or 1/3. Okay, so then this is going to end up being 1/3 x plus 2. All right, so I want you to think, and I'm not going to give this away, but something that I want you guys to think about is what real world situation could be represented with this. I know that I'm going to start with 2 of something. Okay, so maybe I say, I'm going to give you an example, but then you can't use my example. I'm going to say that I have a spinach garden or a spinach plant that is 2 inches tall. It is estimated to grow 1/3 of an inch every week. Okay, so right now my x would represent how many ever weeks I have. My 1/3 is how much it's growing by. My 2 represents its current height. Okay, so being able, this is your step right here where we talk about that real world application, which we'll start looking at more as we get closer to your summative. At the end of this unit, you guys are going to have a real world application element where you're going to have to create a situation where there's a graph and a story that goes with it. So I just wanted to give you that example so you can see it. So from here, you guys are going to head over to your link into Edge Elastic, and you guys are going to create, or not create, but finish up your practice problems that go with this lesson. And if you have questions, please set up office hour times on the Google form or shoot me an email. I'm happy to help. Thanks, guys.